Session 3.3 Measures of Relative Standing and Boxplots. Okay, let's answer these questions. Who is taller, a man 73 inch or a woman 68 inch? The answer is pretty obvious, right? You're gonna say A. Of course, it's gonna be the man is taller. However, think about it. Men are taller than the woman on the average. So let me rephrase these questions and ask again. Who is taller relative to their gender? A man 73 inch or a woman 68 inch? So how can we answer like this kind of the questions? We are compare the height, who is taller. We want to relative to their gender. So one way to answer this question is with a C-score. So what is the C-score? C-score of an individual data value tells how many standard deviation that value is from its population mean. Example, a value 1 standard deviation above the mean has a C-score of 1. A value 2 standard deviation below the mean has a C-score of -2. First, let's look at the formula. How can we find out the C-score? So you can see this is a sample formula for the C-score. You have the value of your x, just like your 73 inch or 68 inch. And then this is the notation of the sample mean, right? Sample mean. So the value of x minus the sample mean divided by sample standard deviation. So this is how you guys figure out what is the C-score. And this is the population formula for the C-score. Same idea, the value of x minus population mean divided by population standard deviation. We assume this is a normal distribution. And the mean that will be in the middle here. So we're gonna say the C-score will be equal to 0 from here. And this means like the mean plus 1 standard deviation. So that's a 1 standard deviation above the mean. So that's why the C-score is going to be equal to 1. This one, that means 2 standard deviation above the mean. So this is the C-score equal to 2. Okay, just like here. This is mean minus 1 standard deviation. So we say there's a 1 standard deviation below the mean. So the C-score is going to be -1. So back to these questions. If we want to find out who is taller relative to their gender, the first thing we need to do, we want to convert it to the C-score. Okay, you can't compare these two numbers. We have to convert it to the C-score. They do have the same unit. Now you could compare who is taller. Okay, example. The mean height of an adult man in United States, population mean equal to 69.4 inch and population standard deviation equal to 3.1 inch. The mean height of the woman in United States, population mean equal to 63.8 inch and population standard deviation equal to 2.8 inch. Who is taller relative to their gender, a man 73 inch or a woman 68 inch? First, I want you guys to use this formula. Figure out what is the C-score for the man's height. First, find out the man's height. The man is 73 inch, right? So 73 minus the population mean divided by population standard deviation. Okay, plug into the formula and then use your calculator. You should get 1.16. Okay, this is the C-score, 1.16. Now, find the C-score for the woman's height. Use the same formula. Okay, check your work. You should get 1.5 here. So think about it, who is taller relative to the gender? Both of them have the C-score 1.16 and 1.5. Let's look at the picture here. So 1.15 about like here, and 1.5 is gonna be here. Right? So you can see woman is taller. Okay, woman is taller. The height of the 73-inch man is 1.16 standard deviation above the mean. The height of the 68-inch woman is 1.5 standard deviation above the mean. So when you compare this number, you're gonna know woman is taller relative to the gender. Okay, using C-score to identify unusual value. Remember unusual value? We talked about this guy on the session 3.2. I say every time when you see usual or unusual value, you need to remember the range rule of thumb. Okay, if you don't remember this part, review the session 3.2. So remember the formula, the minimum usual value and the maximum usual value. That will be the mean minus 2 standard deviation, and the maximum usual value, the mean plus 2 standard deviation. And we have this picture on the session 3.2, right? So mean minus 2 standard deviation. This is the minimum usual. Maximum usual, mean plus 2 standard deviation. So mean plus 2 standard deviation, we're talking about here. This is our maximum usual. Minimum usual will be this guy. So if your x is lying in between the minimum usual and maximum usual, we call this is gonna be your usual value. However, if your x, the value of x is less than the minimum usual, we call this is unusually low number. And if your x, the value of x is greater than the maximum usual, we call this is unusually high. Okay, this is what we learned from the session 3.2. Now we know how to find the C-score. You can use the C-score to find out if the value of x is going to be usual or unusual. So think about it. By the range rule of thumb, if the mean minus 2 standard deviation, this is called minimum usual. And this is the same definition for the C-score here, right? You have a 2 standard deviation below the mean. So the C-score is going to be equal to negative 2. If you can find the C-score is in between negative 2 to positive 2, just like this, then you're gonna know the value of x will be the usual value. If your C-score is gonna be less than negative 2, strictly less than negative 2, it's gonna be lying from somewhere like here. So we call this as unusually low. If your C-score is gonna be greater than 2, so somewhere like here, that means your value of x is going to be unusually high. So we do have a two method to identify the unusual values. Either you use the range rule of thumb or you could use the C-score. Let's try this example. Assume a large sample of adult means has pulse weight with the sample mean 67.3 beats per minute and sample standard deviation equal to 10.3 beats per minute. A man is measured his pulse rate 48 beats per minute. Is his pulse rate unusual? So we have the sample mean, we have the standard deviation in here. And also the value of x will be equal to 48 beats per minute. So let's try to use the C-score to find out if the pulse rate is going to be usual or unusual. Okay, first step, plug into the formula, determine your C-score. Okay, plug it in. You should get negative 1.87. So C squared equal to negative 1.87. And that is in between negative 2 to 2, right? So we know that his pulse weight is usual. For this example, you also use the range of from formula. Find out the minimum usual, find out the maximum usual, and then look at the value of x is going to be in between or less than or greater than. For the section 3.1, we study measure of the center. We know how to find the mean, median, mode, and the mid-range. And all this data is going to be focused on the center. However, sometimes we may want to find out the position of the data other than the center. So to get more detail for the distributions, we want to learn the percentiles. Okay, what is the meaning of percentile? We assume this is going to be the normal distribution, and this is going to be including all the data. So the 100% of the data is going to be lying from here. Now, what is the meaning of percentiles? We're going to divide it into 100 parts. And for each part here, this is the first part, I cut it out. The area to the left, this is about like 1%. So we call, this is going to be the P1. Okay, and then we cut it another part. This is also 1%. So the total area from the left here, this is going to be 2%, right? So this is going to be the P2. Okay, so you're going to keep going. You will have cut one more part here. This is 1%. So the total area from the left, that will be 3%. So that will be the P3 in here. Okay, think about it. If I cut it half in here, how can I call this guy? Cut it half. So the area from the left here, it should be 50%. So I call P50. Okay, one more. How about this one? If I call, this is the P60. Think about it. What is the total area from the left in here? It should be 60, right? 60% of the area here. And what is the meaning of P60? P60 means we do have a 60% of the data below it. Okay, this is a 60% of the data below it, and we do have a 40% of the data above it. Okay, same idea for this guy. P50, 50% of the data below it and 50% of the data above it. So this is the meaning of percentiles. So now we want to find the percentile of a data value. So we do have this formula. I want you guys highlight this formula. Percentile of a value x equal to the number of the values below it. Okay, make sure you count for the below the value of x divided by the total number of values n. How many data do you have? And then times 100. Make sure you always want it to the whole number. Okay, remember how to do the rounding? If that's a greater than 5, you're going to add 1 from there. If that's a less than 5, you want to replace by the 0. Okay, just like the regular rounding from the algebra. Example 3. Table below lists the same airport Verizon cell phone data speed. So you can see I do have all the data speed in here. And look at the data. They already arrange it in increasing order. Okay, you're going to look at it from the left to the right, increasing order. 6.2, 6.5, 7.7, 7.9, and they keep going. Okay. Find the percentile for the data speed of 11.8. Okay, find the percentile for the data speed of 11.8. First, look at the data. Did you guys find out the 11.8? It should be here, right? So I want to know for this data, how many percent of the data below it and how many percent of the data above it. So we're going to apply this formula. So first, figure out number of the values below x. So how many data below 11.8? So you're gonna count from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 and 20. So I know 20 data below 11.8 in here. Divided by the total number of values n. So how many data do you have from here? You have 10, 20, 30, 40, 50. Okay, so that will be 20 divided by 50 and times 100. Use the calculator, you're gonna get 40. Okay, that means P40 equal to 11.8. Means there are 40% of the data below 11.8 and there are 60% of the data above it. And we call this is going to be percentile. Okay, I want you guys try to find the percentile for the data speed of 15. Okay, check your work. So the data speed 15 is like here. So you're gonna count how many data below 15. You have a 10, 20, and 28. So 28 data below 15 divided by the total number of values, which is gonna be 50. So you should get 56. So I could say 56 percentile, that will be equal to 15 in here. Okay, that means there are 56% of the data below it and there are 44% of the data above it. Okay, so this is the first part. If I give you guys the data, I want you guys figure out the percentile. Then you want to use this formula. Now we want to do another way around. Let's say I want to find it out, the P60. I want to know which data is going to be on the 60 percentile. So we're going to follow this procedure, converting a percentile to a data value. First, make sure data are arranged in increasing order. Then you're going to apply this formula, okay? L equal to K over 100 times N. So N represent the total number of values, okay? What is the sample size? The K here represent the percentile. For example, I want to find out the P25, okay? The 25 percentile, so K equal to 25. And then the L, located that gives the position of value. Okay, keep in mind, highlight this one. The L is not your final answer. This is tell you guys what is the position of the value. And then if L is a whole number means like 1, 2, 3, 4, 5, that's a whole number. Then the K percentiles is the average of the number in the position L and the number in the position L plus 1. For example, let's say you find your L equal to 10. 10 is a whole number. So you want to find the number in the position 10 and the number in the position 11. Or you always want to add 1 forward, 10 and 11. Okay, and then find the average of these two data. That will be your percentile. If your L is not a whole number, that means that's going to be the decimal. Okay, like 2.5 or 3.7 or 4.1, that's not a whole number. You want it up to the next higher whole number. I want you guys to highlight this one. Want it up to next higher whole number. Okay, forget about the rounding rules. You always want it up. Even though you get like 2.1, you want to want it up to 3. Okay, even though you get like 5.002, you want to want it up to 6. And then after you want it up, the P percentiles is the number in the position corresponding to the one up value. Okay, let's try to do the example and explain like these two parts here. Okay, find the value of the 25 percentile. So this time I give you guys the percentile. And I want you guys to find out which data is going to be on 25 percentile. So we're going to apply this formula. Okay, P25, so that means your K equal to 25. And remember what's your N? N is going to be the number of the values. So we do have a 10, 20, 30, 40, 50. We do have a 50 data on it. So plug it in. Use a calculator. You should get 12.5. Okay, 12.5. So is a 12.5 is a whole number? No, right? This is not a whole number. So what we're going to do, we want to round it up. Make sure you always round it up for this kind of the questions. So 12.5, after we round it up, that will be equal to 13. Okay? Again, 13 is not your final answer. It only gives you the locator of the position value. So 13. So you're going to count it from your data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, 13. So your P25 will be equal to 7.9. Okay, one more time. Plug into this formula. If you have the decimal here, you always round it up. After you round it up, you're going to count from the data of the position. So 13. So 10, 11, 12, 13. So P25 equal to 7.9. Okay, try this one. Find the value of the 70 percentile, P70. So same formula. Okay, plug it in, use a calculator. You should get 35. Okay, is 35 is a whole number? Yes, right? 35 is a whole number. So we're looking for the position of 35 and 36. Okay, 35 and 36. You're going to find L and L plus 1. So look at the data here. 10, 20, 30, 31, 32, 33, 34, 35, and 36. So I have these two data, okay, 35 and 36, which are 18.2, 20.2. After you get these two data, you want to find the average of these two data. Remember how to find the average? Add it up and divide it by 2. So you should get 19.2. Okay, next one, quartiles. Quartiles are measure of location, denote Q1, Q2, Q3, which divide a set of the data into 4 groups. Okay, look at this example. We're going to divide it into 4 parts here. And we assume you do have an equal area for each part. So we divide it into 4 parts. So the first one here, we call this is going to be a Q1, Q2, and Q3. And think about it. What is the area for the Q1 here? The total data is 100%, right? We divide it into 4 parts. So it's going to be 25% for each part here, right? 25%, 25%, and 25%. So you know that the area from the left of the Q1 will be 25%. And the area for the Q2, the total area here should be 50%. Q3, that'll be 75%. We just learned about the percentiles, and then now we know the quartiles. Think about it, if there are 25% of the area from the left, how to call this one in percentile? We're gonna call, this is gonna be P25, right? P25. And this one, we do have a 50% on the left. How to call this one in the percentile? This is going to be P50. Same idea for this one, there will be P75. So if you want to find the quartile, we're going to apply the same procedure, same formula, just like the percentile. But if you want to find the Q1, since you know this is equivalent to P25, so when you guys use this formula, you're going to plug in K equal to 25. If you want to find the Q2, this is equivalent to the P50. Okay, so your K equal to 50. And again, Q2, that will be equivalent to the median. Remember when you guys learn how to find the mean and median at the section 3.1? This is exactly the same procedure to find the Q2 also. Okay, Q3, that will be equivalent to the P75, so K equal to 75. Okay, definition, a Boxplot, or you could call the box and whisker diagram. It's a graph of the data set that consists of 5 number summary, minimum, Q1, Q2, Q3, and maximum, okay? 5 number summary. I want you guys highlight this one. On the midterm, I may ask you guys, find the 5 number summary. So you're gonna remember, 5 number summary, I'm talking about the minimum, Q1, Q2, Q3, and the maximum. Okay, let's try this example. For the data set, this is gonna be my data. Find the 5 number summary, okay? Find the 5 number summary. So first, I want you guys find out the Q1, Q2, Q3. Let me show you guys the Q1. So N. N means how many data do you have? So you're gonna count from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so N equal to 10. First one, I want to find the Q1, okay, Q1. So remember Q1 equal to P25. So K equal to 25 here. Okay, I plug into the formula. Q1 means P25, so K equal to 25. Divided by 100 times 10, we have a 10 data. So you should got 2.5. So is the 2.5 is a whole number? No, right? This is not a whole number. So we're gonna round it up. That would be equal to 3. Now we're gonna find out the position of 3 here. 1, 2, 3, right? So my Q1, that is gonna be equal to 71. Okay, I want you guys try to find the Q2 and Q3. Okay, check your work. Q2 equal to P50, right? So K equal to 50. And then you're gonna get the 5. And 5 is a whole number. So we want to look for the position 5 and 6. Okay, always plus 1, 5 and 6. So look at the data, 1, 2, 3, 4, 5, 6. So it's gonna be 78 and 89. Now, find the average of these two numbers. So add it up, divided by 2. You should get 83.5. Okay, Q3. Q3 equal to P75. So K equal to 75. You should get 7.5, right? And this is not a whole number. You round it up, that will be equal to 8. Look at the position 8. 1, 2, 3, 4, 5, 6, 7, 8. So your Q3, that will be equal to 124. Okay, after you find the Q1, Q2, Q3, you're going to look at the minimum and maximum. Minimum, that will be 8.5. Maximum, that will be 150. Okay, so this is my 5-number summary. Minimum, Q1, Q2, Q3, and the maximum. Okay, now you know how to find the 5-number summary. The next part, we need to know how to draw the box plot. So this is my 5-number summary from the previous example. And I see the range is going to be from 8.5 to 150. So first, I'm going to draw the scale here. You don't have to start it from the 0. It depends on the data, okay? Since I have 8.5, it's really close to 0. So that's why I started from the 0. Now my minimum is going to be 8.5. So we're going to draw a line here. This is the minimum and I have 8.5. And then I have a 71, which is going to be my Q1, 83.5, which is going to be my Q2. And we have a 124 for Q3. Last one, that will be the maximum, 150. I use the 5 line to represent the 5-number summary. Now, I will use the Q1, Q2, Q3 to construct a rectangular box. And at the end, I'm going to use a line to join this 5-number summary together. So this is going to be a regular box plot. Okay, determine the skewness from a box plot. So look at the picture here. After we construct the box plot, you could tell the distribution. Like this one. This is the box plot here. I have the minimum, Q1, Q2, Q3, and then this point here is going to be the maximum. You're going to see the cross in here. This just means the outliers. Okay, we're going to talk about this guy like after this slide. So you can see the Q2 here. This is Q2 or median. If the median is really close to the Q1, then the Q3. Or the upper whisker. Upper whisker is talking about this line. Upper whisker is longer than the lower whisker here. The data are skewed to the right. Remember, data skewed to the right means the white tail is longer. If your Q2 close to Q3 than the Q1, or the lower whisker is longer than the upper one, then this is going to be skewed to the left. Means left tail is longer. Last one. If the Q2 is going to be in between Q1 and Q3, and these two lines is about the same length, this is what we're looking for, and we say this is approximately normal distribution. Okay, remember what's the normal distribution? Data starting from low, which to the maximum, go back to low again. It's like the bell shape, and it's about like symmetric. Okay, normal distribution. Okay, after we know how to construct the regular box plot, now we want to determine the outlier. Okay, after we determine the outlier, we could construct the modified box plot. So definition, interquartile range, IQR, okay? You need to know how to find the IQR. IQR is going to be the difference between Q3 and the Q1, just subtract it. And we're going to use the IQR method for finding the outliers. Okay, one more time. Remember what is the outliers. We talk about it in the chapter 1 or chapter 2. Right? Outlier means you do have some data is far away from the majority. Okay, it can be by mistake or it can be the real data. Okay, it's just far away from the majority. We call that an outlier. So first, find out the Q1, Q3. Okay, first step, you always find out the 5-number summary. And you know the Q1, Q3, you're going to find out the IQR. Okay, find the difference, Q3 minus the Q1. And then find out the lower outlier boundary and the upper outlier boundary. Lower outlier boundary will be the Q1 minus 1.5 times IQR. Okay, IQR is going to be from here. You get it from the step 2. And then upper outlier boundary, Q3 plus 1.5 times the IQR. Okay, you're going to find out 2 numbers. And then any data value is less than the lower outlier boundary or greater the upper outlier boundary. We consider this is going to be your outlier. Okay, let's try the example. Okay, example 8, number of absence in January 2008 in the middle school. So I do have the data in here, and all the data is arranged in increasing order. So first, find the 5-number summary for the regular Boxplot. Okay, just like the previous example, I want you guys find out the 5-number summary. Okay, so we do have a 22 data, and I'm gonna use this formula. So want to find the Q1, so Q1 K equal to 25. So you're gonna get the decimal, rounded up to the 6. So the position value of 6. So 1, 2, 3, 4, 5, 6. So you're gonna find out Q1 equal to 45. Okay, then Q2. You're gonna get the whole number, so you want to find the position 11 and 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So you have a 251 in here. Find the average of the 251, which is gonna be equal to 51 again. Q3, you should get not a whole number, so rounded up to 17. Position of the 17 value, that will be 59. Okay. Then 5-number summary. So what is the minimum and what is the maximum? You should get this. Okay, minimum is 41, maximum is going to be 100. Okay, and I have a Q1, Q2, Q3. So this is the 5-number summary. Okay, B. Find the lower outlier boundary and the upper outlier boundary, and find the outlier if it exists. So first, I want you guys find out the IQR. Okay, IQR equal to Q3 minus Q1. You have the Q3 here, you have the Q1 here. You should get 14. And then use these 2 formula. Find out the lower outlier boundary and the upper outlier boundary. Make sure here you're gonna multiply 1.5 to the IQR first before you subtract from the Q1, okay? Okay, check your work. You should get 24 for the lower outlier boundary. And you should get 80 for the upper outlier boundary. Okay, after you found the boundary, you're gonna look at the data here. 24, somewhere like here. Okay, 24. And 80 is gonna be in between here. Right? This is gonna be the 80. And again, this is the outlier boundary, means any data less than the lower outlier boundary will be the outlier. Do we have any data less than 24? No, right? How about this one? Any data greater than 80? We do have the 100 in here, right? So that means 100, that will be your outlier. So write it down. Find the outliers if exists, right? So outlier is going to be equal to 100. Okay. C. Find the maximum and minimum again, and then construct a modified Boxplot. Okay, we may want to change the minimum and maximum. It's gonna be different from the part A here. Okay, the part A, we didn't find out the outlier, so 41 and 100, that'll be minimum and maximum. But after the part B here, we know 100, that'll be my maximum. So you have to think about it again. What is the minimum and what's the maximum? Minimum will be 41 here, okay? You never use the 24 and 80 from this example because 24 and 80, this is just the boundary. This is not part of your data, okay? So minimum, that will be 41. And how about the maximum? Maximum, that will be 77. Okay, maximum, that will be 77. So write it down here. Minimum 41, maximum 77. Now we want to construct a modified Boxplot again. So we have the data from 41 to 100. We need to include the outlier because this is part of our data. So I'm gonna starting from 40 to 100. Again, you don't have to start it from the 0, okay? Depends on the range of the data here. Okay, my minimum is gonna be 41, somewhere like here. And then my Q1, 45, Q2, 51, Q3, 59, and the maximum, 77. And then I'm gonna use the Q1, Q2, Q3 to construct a rectangular box. And then I will use the line to join these 5 number summary together. We are not done yet. We do have the 100 outlier, and I will use the star to represent it. So this is gonna be your outlier, and this is my modified Boxplot. Okay, this is how you guys use the TR-83 plus or TR-84 plus to find the 5 number summary and construct the Boxplot or modified Boxplot. I'm gonna show you guys the example. First, click on the step. Go to number 1 added. And then on my L1, I'm gonna input my data. So I will have 12, enter, 12, enter, 13, 14, 16, 17, 18, and 30. And then I'm gonna click on stat. Use the right arrow button to the cell. Choose number 1, one variable statistic. Okay, remember for this screen means I need to set up my calculator first. So I'm gonna click on the mode. Final the stat visual here. Turn it off. Okay, turn it off. And then quit. So click on second mode, you're gonna quit. Okay, go back to that one. Stat, cal, choose number 1, one variable statistic. And my data is gonna be on L1. So I'm gonna put second 1 for L1. And then enter. So I do have an n equal to 8, means I do have 8 data. Let's go down here. You could see the minimum Q1, median means your Q2, Q3, and also the maximum. So it should be 12, 12.5, 15, 17.5, and 30. So you guys can use your calculator to double check your work. Find out the 5-number summary. Now I want to use the calculator to construct the boxplot. So I'm gonna click on second stat plot. Make sure you turn off number 2, number 3, and number 4. So I'm gonna enter for the number 1, turn it on. Go down, use the arrow button to go to the right. You could see the 4th one, that's a dot here. This is a modified boxplot. Next one here, this is the regular boxplot. So let's construct the regular boxplot first. Click on enter. My data is gonna be on L1. Okay, now click on the zoom. Okay, some calculator, you're gonna see this socket key here. You could just click clear. Okay, and then click on the zoom again. So go to number 9, zoom step. You're gonna see this is the regular boxplot. If you want to see the number next to the zoom, you're gonna see the chase. Okay, do you see the medium means your Q2 is 15? You could go to the left to see the Q1 and minimum, Q3, and also the maximum. Okay, now let's construct the modified boxplot. So we're gonna do it again. Second stat plot, enter for number 1. So go down, I'm gonna choose the 4th picture, enter. My data is gonna be on L1. The mark here, it just shows the outlier. So it doesn't matter which one you're gonna pick. Click on the zoom again. Choose number 9, zoom step. Okay, you're gonna see this is the modified boxplot. Click on the chase. You see the minimum, Q1, Q2, Q3, and the maximum. You could see the dot here, the cross here. This is what percent your outlier. Outlier is gonna be 30. Okay, take advantage of your TI calculator. You could double check your work on the exam and for the homework. That's it for the session 3.3.